Good morning, everyone. Thank you for your time today. My name is Mylin Trong, and I'm the Unmanned Laser Scanning and UAS Business Segment Manager for RIEGL USA, located in sunny Orlando, Florida. Today, I'll be presenting on the benefits and highlights of RIEGL's UAS LiDAR solutions, which will feature insight into RIEGL's foundation into the commercial UAV LiDAR marketplace, the key differences between the RIEGL unmanned LiDAR product line, and our system integrations to maximize your overall use cases. About RIEGL, we are a leading and established LiDAR manufacturer that provides engineering and survey-grade accuracies for a multitude of UAS applications. Specifically, we provide dense, accurate, and feature-rich data, and we offer an efficient and precise data capture software workflow based on our streamlined acquisition and post-processing software suite. Although the commercial UAV marketplace emerged and developed over the past several years, RIEGL's unmanned technology has developed a long line of UAS-specific sensors, establishing a historical foundation of 15 years. Although the first RIEGL UAS sensor was released in 2005, it wasn't until the introduction of the then-named VUX-1 in 2014 where this compact and lightweight UAS sensor really set the stage as the commercial UAV marketplace began to grow exponentially. Later renamed to be the VUX-1 UAV, it is this scanner that built the foundation of RIEGL's UAS LiDAR product family, with further developments every year since then. In 2016, with response to the size and weight, we introduced the MiniVUX-1 UAV, which is suited for smaller UAS integrations. In 2017, we offered the MiniVUX-1 DL for downward-looking, optimizing for corridor mapping applications. In 2018, we introduced the VUX 240, which is double the pulse repetition rate of the VUX-1 LR, the longer range variant of the VUX-1 UAV, and both offer a dual usage for both unmanned and manned aerial scanning applications. And in 2019, we introduced the MiniVUX 2 UAV, offering double the pulse repetition rate as the MiniVUX 1 UAV. And with this large product portfolio, how do you decide which is best for you? Besides the overall size, weight, and of course cost, it really is application dependent. It's not necessarily a one-size-fits-all, but it can be a one-size-fits-most. In the end, it's a relationship that weighs the overall weight of the payload, the measurement ranging capability, and the overall point density that the system can provide. With the MiniVUX 2 UAV, it offers double the performance of the MiniVUX 1 UAV. With the MiniVUX 1 UAV, still the smallest and lightweight offering that we offer for UAS LiDAR scanning, and it is a cost-effective survey-grade accuracy UAV LiDAR scanner. And with the MiniVUX 1 DL, its reduced field of view offers a high concentration of all the laser pulses, and this gives you 100% of those pulses on the ground, giving you a beneficial application for corridor mapping. With the VUX series, the VUX 1 UAV offers 5 times the laser performance over the MiniVUX 1 UAV, so it provides a cost-effective survey-grade accuracy solution, whereas the VUX 1 LR offers a longer range capability for the VUX 1 UAV with a slight increase in cost, and that gives you a cost-effective LiDAR solution for both UAV and manned aerial applications. And with the VUX 240, double the performance of the VUX 1 LR, is even more suited for beyond visual line of sight applications as well as manned aerial applications as well. After selecting the LiDAR sensor that makes the most sense for a usage application and selecting the appropriate Planix IMU GNSS, we also offer optional cameras to be co-integrated to provide a more complete solution. Specifically from Sony, the A7R3, which is a 42 megapixel camera, and the Sony A6000, a 24.3 megapixel camera, both are offered in a native configuration. And more recently, the optional multispectral lens configuration of these camera types. From phase 1, we offer the IXM 50 or IXM 100, both 50 and 100 megapixel camera options. And if RGB is not of interest to you, we also offer a thermal camera integration from FLIR. And because of its small footprint, it can also be offered in conjunction with the RGB camera if you're interested in both. So far we've addressed the topography mapping applications, but for topobathymetric, for shallow water mapping, we offer the VQ840G, which is our compact 3D topobathymetric laser system, making use of a green scanner and offering an elliptical scan pattern with a depth penetration of up to 2 Secchi depths. Its usage is applicable to both large UAV applications as well as manned helicopter applications or even fixed wing applications, depending on the overall size of your project site. Taking a dive into this sample data from our topobathymetric system, cutting a cross-section of this data, you can see easily identified the surface of the water body, as well as the terrain surrounding it, as well as the terrain underneath the water body. And in this site, flown in Austria, on a helicopter flying at an AGL between 75 meters to 150 meters, we're getting an average point density of 50 points per square meter with a initially measured depth of 3 meters, which equates to a Secchi depth of 1.4 meters in this site. After selecting your LiDAR payload, you of course need a UAV to mount it onto. And in that case, we offer the RIEGL RICOPTER UAS, which is our fully integrated turnkey solution, optimized for operating RIEGL's mini-VUX and VUX system payloads, which includes the co-mounted cameras with a maximum takeoff mass of under 55 pounds or under 25 kilos. This offers a max payload lift capacity of 6.5 kilos, and it is a fully redundant and compact multi-rotor UAV. The RICOPTER UAV system overall is comprised with the aircraft as well as its accessories, the pilot transmitter or the drone controller, the batteries plus the charging control unit, takes about an hour to charge the full set, and the ground control unit. Then of course you have your payload, so it'll lift our mini VUX system, our VUX series systems, and then for our bathymetric configuration, and we offer a heavier lift, RICOPTER M. This can also lift the VQ840G topobathymetric system. For a smaller and alternate turnkey integration, we offer the Integration 600, which is optimized for a mini VUX systems onto multi-rotors like the DJI Matrice 600 Pro, but of course it's not limited to it, and is essentially for any multi-rotor that is capable of lifting this payload, and makes use of the 4 attachment points for vibration dampening. The LiDAR system is controlled via a 3-way switch powered by the PWM signal. Easy to boot up, data collection, and it is essentially a full turnkey solution besides the UAV itself. Once you've captured your LiDAR data, you've brought it down to go in data process, you've registered your georeference and colorized the point cloud, you can get something what is seen here, which is our colorized LiDAR point cloud of RIEGL USA's new headquarters, which is under construction. And in this case, we've captured it with our mini VUX system mounted on to an M600 Pro using our integration kit that I just mentioned. And all of this is managed through our RIPROCESS software suite. The visualization, the data adjustment, the registration of the data to itself, applying ground control, and colorizing it, which ultimately allows us to export our precise and georeference point cloud to a variety of file formats supported for further feature extraction and analytics within a third-party software. So thank you so much for joining me for the benefits and highlights of RIEGL UAS LiDAR solutions, where I address the insight into RIEGL's foundation into the commercial UAV LiDAR marketplace, discuss the key differences between the RIEGL unmanned LiDAR product line, and different system integrations that we offer to maximize your overall use case. I look forward to working with each and every one of you and seeing how RIEGL can assist your business, and I look forward to your questions. Thanks so much.